Hello everyone, I'm Zhongzhou Wu. Our group is going to give you a presentation today. This part is the introduction. The theme chosen by our group is about ultra-reliability and low latency. The report first selected 7 papers on ultra-reliability and low latency. Through our discussion, we finally designed it to choose the article backwards composite feedback for configurable ultra-reliability of retransmission protocols, which was published by Said et al. These documents mainly emphasize how to achieve ultra-reliability communication, so we mainly display from literature review, selected report analysis, simulations, personal evaluation, and general comments, and probes future investigation or research problems. Here is next part.
Hello everyone, I'm Pei Feng. I'm going to talk about the analysis of our selected report. The main purpose is to achieve ultra-reliable and also try to not increase much latency by using retransmission protocols. What is the meaning of reliable transmission? The basic idea is to ensure no packet loss during the transmission. After the receiver receives the packet from sender, it will return an acknowledgement to sender. The positive acknowledgement is ACK, means successful transmission, and the negative acknowledgement NAK, means unsuccessful transmission. And in picture A, there is no loss, while in picture B, the packet 1 is lost. Receiver will not send an ACK, so after the timeout, the sender retransmits the packet 1 again, and so on. During this kind of method, we can achieve high reliability. Then the authors also obtained the trade-off between the latency and reliability through 5 different feedback approaches. After that, they proposed a solution called backwards composite feedback, which carries out operations at receiver and transmitter to provide high reliable with unreliable channels. Thank you very much, and now let's turn to Shihao.
Here are some simulations for our selected report. And first is PCF transmitter operations. Here's an algorithm for the transmitter modes. The transmitter gets the composite feedback from the receiver, and it needs to analyze whether it is ACK or NAK, and then it needs to output the transmit packet and new data indicator to the receiver. And for the receiver, it gets the observed new data indicator and the packet from the transmitter, and it needs to analyze whether it is toggled, and if it is toggled, then this packet should be new, and if it's not, it need to use this lookup retransmission index functions, and then decode it to give the composite feedback to the transmitter. Here's an example for the composite ACK. And it's obviously that here are 5 occurrences that if the first occurrence got the positive composite feedback, then the second occurrence will put a new data packet will be put in the second occurrence. Inversely, if it get the negative positive compositive feedback, then the next one should be then actually it need to be the retransmission phase, and next occurrence should be the last data packet. Here's the results. Here's the packet delivery latency for these 5 modes. Actually, this method is only have limited average longer latency than the traditional ARQ, but it's still low latency. And here's the reliability. It achieves ultra reliability, and here are some examples for and the different modes of SCW, and R1 to R6 are complementary cumulative density functions of packet deliveries. And welcome to the next.
Hello everyone, this is Sun Yuekan. I will do a personal assessment for this article. This article compares the BCF method with other traditional methods. Compared with the traditional ARQ method, the reliability of the method has been significantly improved, and the error rate is controlled within the actual range. Only the minimum packet delay is required. Compared with the method of repeated feedback reporting, the packet delay of the BCF method is significantly reduced. This means that the method in this report almost replaces the other two methods to some extent. However, the BCF method also has certain limitations. In general, a typical link adoption configuration can successfully decode a high percentage of transmissions, but the BCF method will seriously reduce the system resources optimization. Considering the above points, the BCF method has higher reliability and low packet delay under unreliable conditions. It's an effective solution and a huge breakthrough in current ultra-reliable communication technology. It enables closer to 100% connectivity for ultra-reliable communication in unreliable environments. Thank you. Let's turn to next person.
This is conclusion part. We started the impact of feedback errors on the performance of the closed-loop retransmission protocol and proposed a new method to confirm the delivery of data packets when the feedback is not reliable. Compared with traditional ARQ, the reliability of this method has been improved by several orders of magnitude, while the average experienced packet delay has only a small increase. Compared with only repeating the feedback report to improve reliability, the new scheme has a significantly smaller average packet delay at almost the same packet transmission rate. Therefore, in the future, we need to continue to make further improvements in terms of low latency. That's all. Thank you. This is the part of reference list.